Yo guys, what is up? It's RedEngine. I just wanted to add this quick bit in before, well, not before the video starts, but before the video start, to just say that these devlogs are kind of like a mental log rather than a educational, like, explaining how things work. This is kind of like just watch me build my engine. If you do want more like explanations of things that are going on, like if you want me to explain concepts better or more in depth, I'm happy to do so. But right now, that's just how I'm gonna approach it unless I get feedback that tells me otherwise. Anyway, enjoy. Also, bear in mind I've never done videos of the style, so if you actually have any feedback for doing things differently or how you want things laid out, please tell me, because I'm going in blind. I only watch devlogs, so I'm just doing what I've seen and I have no idea if I'm doing it right. So yep. Right, so for day one here, I basically just focus on the camera, really, the camera GUI, and just optimizing, just getting all the big optimizations out the way. Stuff that would just help me later down the line. Everything in the video was recorded today, or technically yesterday. It was all recorded in the same day, that being the 8th of March, through to 2 in the morning now, the 9th of April. Sorry, yeah, I meant April. It's whatever. Anyway, carrying on with the video. Yo guys, right, so this is what I'm just gonna do is I'm just gonna comment over what I said, because everything I just said was absolute waffle. I'm basically just going with my method and how I plan to approach my camera system and the main things that I want to achieve with it. Because I've technically already got one, but it's just absolutely god awful, and it's not scalable, and it's gonna cause me some grief later down the line, which it did in this video, but all that grief is gone now. So basically, at the moment, or at this current time, at that point in time, my camera system was really slow. Like I just said, it was really bad, and you could zoom in and out and move the camera and everything, which is cool, but the FPS was terrible. I had an option in my engine config to turn the camera on and off and zooming on and off, and it's about like a 200 frame difference with the camera on and with the camera off, which is just terrible. So my goal is to find a way to render a zoom surface or a camera surface without absolutely annihilating the frame rate. So I'll just show you my progress and how I got on with that. Okay, so to explain what my implementation at the moment is I basically got a main camera that can't be changed and is essentially just the screen. Everything is rendered to that camera, and that is rendered straight to the screen. So there's no real true screen space. Well, there's no real true scene elements. Everything is just on the screen. It's just some things are rendered not on the screen, whereas what I need is a viewport / window. You know, I'll explain it in the next speech. But what I mean is that there's the main viewport in the engine, which is quite literally the window and the pixels on that window, which is the viewport. And then the camera's feed, I guess you could say, or information, is fed to the viewport, where you can then see it on your screen, so on the window. And what I'm trying to say is that when a scene is made, each scene will get a main camera, and that camera will go straight to the viewport when you load into that scene. Okay, right. Just saying. I basically was trying to solve a problem I didn't have, and that problem was that I was trying to assign, instead of assigning a camera to every scene, I was assigning a viewport, and it was because half asleep, and I wasn't focusing, so I was trying to solve a problem I didn't have. I didn't need to change the way that scenes are loaded. I just need to figure out my problem. So I'm gonna skip a bunch of information from now on. It's like a bunch, because I'm not even solving like a coding problem. I'm fighting myself at this point. I'm fighting myself to solve the actual problem, not a problem I didn't have. Anyway, I'll just skim over the bits that are kind of important, but not really, but give you some background. Yeah, I don't know if you paid attention to what you just saw there, but where I was defining my camera, I was actually defining a viewport, which is the problem that I'm on about. So I'm just not gonna even keep in the recording that shows how I solved that problem, because like why would I need to? That wasn't the problem at hand. Again, I'm just fighting myself here to solve a problem I didn't have, but it's fine. I'll just move on. Okay, so I didn't rewrite my whole engine. I didn't rewrite my whole GUI thing. I kind of just overestimated my issue. Yeah, no, I just overestimated my issue. I didn't need to rewrite anything. I just needed to fix the code for the camera that I got, because I didn't really do it properly. So I think I'm just gonna skip all the irrelevant camera parts, because there's a lot here that I'm just solving mini problems that you just don't really need to see. But I'll keep the important bits, like right now actually. Alright, so basically what I did, this is editing me, by the way, this is me just explaining the information better. What I did is I managed to get the camera component to hook up to a scene, to an instance of the camera component, and everything in that scene is drawn to the camera, but not to the screen. Then the camera is drawn to the screen, so that everything is contained, all the information is contained within the camera and the scene, rather than the screen, which is what it was before, because the information was contained in the screen and just drawn straight from the screen. Which just makes, basically, in short, it just means that my cameras I can place multiple cameras in a scene, I can swap between them, I can turn them on and off, I can get the texture of the camera into like an image or something. You'll see that later on, by the way. Basically, it's all gonna go uphill from here. All right. So while I just waffle right now, I'm going to just explain my GUI system. So basically, for my GUI system, there are two different types of GUI elements. There is event elements and normal elements. Event elements basically react to an event, such as a mouse click, a button press. So a text box would be an event element, because when you type, it triggers the key press event. A button would be another event element, because you click on it. Things of that nature. And normal elements are just entities that are rendered through the GUI service, which is basically three different groups of sprites. You got the screen UI elements, the scene UI elements, and then the screen scene UI elements. I'll explain what the difference between a scene and a world element is in a second. But event elements are also normal elements, because they're also rendered through the GUI service. Right, now to explain the what I call the spaces type, the space types. There are two space types. There used to be three, but I'll just explain two for now. There are two space types: world space and screen space. And screen space are basically GUI elements that are rendered straight to the screen. They have nothing to do with the camera as such, because they are local to the position of the screen. So things like your main menus or like inventories in Minecraft would be a screen space element, because it's locked at a position on your screen, not relative to the world. Like if you move in Minecraft, your inventory doesn't stay in place. Like your inventory doesn't have its own coordinates. It does on screen, but not in the world. And world space elements are basically elements that have a position in the world. So that's relative to the camera, basically. For example, a player in Minecraft would be a world space element, because it's rendered only in the world. Its information is contained in the world, and where it is on screen is also contained in the world. Like if I move in Minecraft, my coordinates in world space are going to change, although my GUI coordinates in screen space aren't. So that's basically what that is, and you'll see that on screen in a bit. I'll actually just show it now while I'm explaining what the difference between a screen space and a world space would look like using the same element. A good example relative to my game is the text, the debug info on screen are screen space elements, because no matter what scene you go to, they're going to be there. They're actually global elements. I take that back. Global elements are basically screen space elements that aren't in a scene. So that'll be things like the debug info. Like no matter what scene you go to, the debug info is going to show up. Whereas a title in a main menu would be a scene screen space element, because it's screen space, but only for that scene. If I didn't explain that well, just comment that I didn't explain this well. But it was much better than my explanation in the video. Alright, so to explain and shorten everything that I was just saying in this bit, basically, I didn't want to have to optimize my viewport or my camera system anymore, or my GUI system. It would take a bit too long, and it wasn't my goal for today. My goal is to get the camera system cleaned up and everything. So I was looking for other things that I could optimize, and I was checking if text was updating every frame, because one big performance killer is creating your text, creating the surface, and then drawing the text every single frame, and that's very CPU heavy because you're having to make a new surface every single frame. And pygame is purely CPU. You can get like OpenGL like compatibility, but I'm not doing that. But I'm basically only dealing with the CPU in this case. So I found out that text is updating every single frame. So what I'm going to do now is cache it. Alright, sorry. I'm going to explain caching real quick. Caching is basically when you store a value in memory for quick access, rather than recalculating the value, or, well, yeah, exactly. Rather than recalculating or refetching the value, you can basically just store it in memory for quicker access. And in the case of text caching, what I'm going to do is every single time the text is going to get updated from some function, for example, the debug service, whenever the debug service is reloaded or rendered, it will update all the text in the debug service. So every single time the text is requesting to be reloaded, we're gonna store that surface of that text in a cache, so in an array, and then fetch that array if the text that it's requesting to update is the same as the text in the cache. So that way, instead of recalculating the whole service, you can just pull it out of cache. And for text that doesn't change, insane FPS boost. And for text that changes only a little bit, again, insane FPS boost. But on the case that you've got text like, you know, like a counter or something, or text where, like coordinate text, where it's telling you the coordinates of your mouse on screen, you might not get the same coordinates. So you're dealing with the potential to have 1280 times 720 different combinations of text surfaces in memory. So in cases like that, you just got to disable caching and deal with the performance overhead. But it's really a tiny performance overhead, and the benefit from it is insane. Like, I basically doubled my FPS. I went from like 200 300 to 500 400. So that was really nice. So I'll just show the before and after of that. Yeah, by the way, the memory usage isn't that high. It's about the same. It's about 18 megabytes. I don't know. The clip that I just grabbed just happened to have really high memory usage, but it's not that high normally. So moving on to the next issue, because I just re-implemented my camera and hadn't properly like adjusted everything. My text is actually rendering above like the priority that it should be. Like, the text should be rendering to the screen, but then the transition service, which is what smoothly changes between scenes, which you'll see here, the text was rendering on top of that, which was really annoying because that would mean screen elements also render on top of the transition service, which we don't really want. So this is a quick fix. I just had to change the order in which elements were rendered, and I just rendered the transition service straight to the screen rather than through the camera to the screen. Okay, right here is a really good example of a screen element as opposed to a scene screen element. If you look, that car is being rendered on top of on the screen. Like it's not changing, it's on top of the scene and it's on the screen, which is really nice. And I just thought I'd show you this quick clip to show you the difference between scene elements and screen elements. Okay, so the next thing that was on the chopping block now was I wanted to be able to render parts of the scene to a surface texture, similar to like a render texture in Unity. I thought that you could achieve this by manipulating the camera bounds, but camera bounds didn't work the way I wanted to. So I spent like 2-3 hours just playing around with camera bounds. I took a break and just gave up because it was just, as you can see here, look how buggy this is. It was horrible. It was really annoying. But if I didn't play around with the camera bounds, I wouldn't have been able to get my quote-unquote culling. If you don't know what culling is, it's basically not rendering things you can't see. So if, for example, if I'm playing an Unreal game, as in an Unreal Engine game, I don't want to render everything all at once, especially stuff I can't see when it's ray traced. I'll only render what's in the camera, and that's basically what culling is. So I only render everything that's in screen bounds. So I managed to get that to work, as well as what I just mentioned about clipping parts to the screen, and that was achieved by subsurfacing the screen. Subsurfacing is basically getting one part of a surface and splitting it into another part. It's the same way that I do sprite sheets with. You just chop up the sprite sheet surface into small surfaces, which is how then the sprite stack works as well. Yeah, I'll just show you the finished product here. Okay, yo guys. So recording corrupted, so I'm just gonna record some quick footage of stuff that I wasn't able to catch. First of all, crop surface textures are now a thing. Very simple, not really any FPS. Yeah, they don't really make a dent in the FPS. You can this is the real car, and then this is the surface rendered car. So this is a crop part of the scene camera, the main camera, that is being rendered here. I've implemented camera controls too. They behave the exact same with the crop texture. Camera controls are way smooth. This is me moving around the world, not the world moving around me. Or technically it is. The world is moving around me, but in this case the car's world position isn't changing. Yeah, as you can see, the crop surface texture is quite literally just in this case it's a 200 by 200 snippet of the center of the screen, just rendered in the corner there. I might add a dedicated GUI element for it so that it can be rendered in screen or world space. Probably what I'm going to do tomorrow, because it's 2 in the morning. I'm editing the video. I'm going to try to get it out tonight. What else? That's really it. Yeah, so the camera can be controlled now with offsets and whatnot, and believe it or not, you can actually run scenes in each other. So I can run scene 1 and scene 2, but you can't render textures, sadly, because you can't run the camera. That's the whole thing that I'll hopefully give a demo at some point, but not today. It's very unstable, but once I get it working better, I'll showcase it. Right, quickly just gonna clear up some things that I didn't mention. You can, sorry, I improved my sprite stacks. You can actually change the spacing now and change the camera in which they're rendered on. That still doesn't really work because it's not really a use case for it, and I don't plan to really add anything to it. As of plans for next video, hopefully I'm going to fully finish my camera. Maybe I'm going to revisit GUI. Shadows is a thing that I want to look at, and Discord rich presence. And that about wraps it up for this video, guys. Thank you so much for watching. Send this to a friend, like, subscribe. Appreciate all you guys. Bye.